here is to build a piecewise function that changes definition at x equals 0. And at the moment, it is only defined for x greater than 0. So if you asked what is f prime of 0, the answer would be undefined. Because when we're doing our draw the tangent line process, you have to be able to take the point and move in both directions. And I can't move backwards because there's nothing to move on to. I would just fall off the edge of the world. So here, this is not even defined at 0. But even if I changed it, the function is not defined at 0. But even if I changed this function so it's greater than or equal to 0, this still f prime of x would still be undefined. Now, everywhere else, it's defined, everywhere greater than 0, this function is defined, and it would be f prime of 0 is undefined, and you're absolutely right, f prime of x is equal to 3 for x strictly greater than 0. But we can change this function if we want to. So I'm asking you, can you make this function have a different piece? Like, what formula do you want to give this for x less than 0? Negative x squared plus 3x minus 5. And we're going to make that be the formula for x less than 0. So this is a piecewise function, and this graph is the graph of the entire function now. Is it true that f prime of 0, is it true that f of 0 is defined? Yes, f of 0 is defined. F of 0 is going to be 3 times 0 plus 2. Is it true that f prime of 0 is defined? So I want everyone to stop, if you would, and think about this, because this is a really important concept. We're talking about whether or not it's even possible to define f prime of x at a given number. If I look at x equals 0 and I hone in on that x equals 0, I'm asking, is f prime of 0 defined here? Can you tell me f prime of 0 is this number? How many of you say yes, I have a value for f prime of 0? How many of you say no, I do not have a value for f prime of 0? So the ant rule, I'm glad you brought up the ant rule. The ant rule is for when the limit exists or doesn't exist. So the limit here would not exist because of the ant rule. You're absolutely right. The limit as x approaches 0 of f of x does not exist because of the ant rule. Now that's different than asking whether or not f prime of 0 exists. So even though that's a valid thing, it's used to answer a different question. It's being used to answer whether or not the limit exists. In order to think about whether or not the derivative exists, the derivative is the slope of the tangent line. So if you were going to draw a tangent line at this point, where would you start? Yeah, it's like, okay, so our tangent line motion is supposed to be really smooth, right? So that's the whole point of a derivative, is it gives us a smooth sense of motion. So here I can go back and forth and back and forth and back and forth. Here, if I say, all right, I'm going to go back, whoa, chop it down, whoa, forth, up, whoa, chop it back down, whoa, back. It's not a smooth process. It's not like a roller coaster. A roller coaster is smooth at every point. Would you ride this roller coaster? No, because you're going to fall off at x equals 0. So the derivative here is undefined. F prime of 0 is undefined because the entire point of the derivative is to give us what would the smooth velocity be at that point. And here we would have a jarring, choppy velocity. I can't make sense of a tangent. The reason it's not 3x is that's only the reason that f prime of 0 is not 3 is that that's only the rule if x is greater than or equal to 0. You also have to look at what happens when x is less than 0. So this is another example of a critical point. A critical point is a place on the graph where f prime of x is equal to 0 or f prime of x d and e. And they're really important to find because the intuition here is this is where things get interesting. So f prime of x equals 0, you're going to have a change potentially, or at least you're going to stop for a second. F prime of x does not exist. That's potential disaster. It's a place where the velocity doesn't make sense because there's a sudden sharp change in velocity. What would happen though is you'd be looking at something where they meet, but the shape suddenly changes in a jagged way. So if the shape is changing in a smooth way, the derivative makes sense. If the shape changes in a jagged way, you can't define a derivative. And probably an even more basic example of that is what if we looked at something like f prime of x equals absolute value of x. What's f prime of -5? It's not one. You can see, for instance, that the derivative has to be negative because the function is decreasing at -5. Yeah, so we can say just from looking at it that f prime of -5 has to be negative. F prime of 5 would be -1. You're right, if I drew a tangent line here, it would actually just be the line itself. And you can see if you calculate that this line has a slope of -1. So f prime of 5 would be -1. What would f prime of 2 be? F prime of 2 would be positive. You can see that it's positive because the line is increasing at x equals 1. Now, what would f prime of 0 be? Is f prime of 0 defined? How many of you vote that f prime of 0? You can tell me the value here. Okay, there's a limit. Let's start with that. There is a limit. You're telling me that you see that the limit as x approaches 0. Okay, so the limit as x approaches 0 of f of x, what is it? It's equal to 0. You answered a different question than what I asked, which is okay, because it tells us that we need to clarify this a bit more. The limit as x approaches 0 of f of x is equal to 0. What would f of 0 be? F of 0 is 0, because if you look at the actual x coordinate, 0, y value is equal to 0. Now, what would f prime of 0 be? Undefined. Can you make sense of drawing a tangent line here at x equals 0? If you drew a tangent line, what would it have to look like? Okay, if you're coming from this direction and you're going backwards, if you're coming from this direction, you're going backwards, then you try to go forwards, whoa, it's a totally different line. That's not a line, is it? So you don't have a well-defined, you don't have a well-formulated sense of this is a line. You have, wait a minute, this is really rocky. This is a really jarring motion. This isn't smooth. So in order for the tangent line to even be defined, you have to have a smooth curve where it makes sense to be able to draw the line from both directions and it actually looks like a line. So as you move back and forth, you're looking here at what does this motion look like? No, I'm saying you're looking at what does this motion look like? This motion is not smooth. You would have a really jarring bump. So imagine that you're riding a roller coaster and the critical points are going to be the places where either you turn around in a smooth way or you hit something like this where you're going down and through, or you hit a really jarring bump. This would be a really jarring bump if you were riding a roller coaster, like boom, boom. I don't even think you could get back up from it. I think this would be a crash point. If you actually imagine riding a roller coaster here and you're going, okay, I'm riding this roller coaster down, wish me luck. What happens when you get to here? Bam, you hit the edge of it and you can't come back up. So those are the types of critical points. Critical points are places where that's one way it can happen. It could be a sudden crash. It could also be that the f of x is undefined.